Start to record.
And ask for something and also one for answer
What happened to this now?
chat. Okay, so let's move on. And yeah, so in the last slide we saw software. Software actually is not the whole thing. We have multiple components. Within components, we saw there can be multiple objects, right? And those all the whole software is actually sitting inside a system, right? And we can have multiple software inside one system. Now, what actually is acceptance testing? So acceptance testing actually means once the software is actually being developed, before the user actually uses it, we need to approve whatever functionality for which it was designed. Is it doing those things or not? If the intention is like, for example, in our case, if the whole system, for example, in this client's side service. So in client side service, if we are trying to develop something, we may use JavaScript programming, right? And we can design an end user platform with the help of which users give certain input, right? So in this case, what can be the acceptance testing? Acceptance testing can be whether that platform is taking the input or not. If it is taking the input in the right way, we can say it has passed the acceptance testing phase, right? So similarly, for different modules, we can have different acceptance testing. For example, for server also we can have whether we can retrieve the desired information from server or not. If we are giving a command with the help of which we need a customer whole information about his documents, about where actually he is living, about his qualification, can we actually get those information from server or not? So if we can actually get those information from server, it means it has passed the necessary acceptance testing. So acceptance testing in this is here. It means like, does the software pass the normal functionality test, means for which it was designed, whether it is doing those things or not. So yeah, so this diagram, I think everyone knows software development life cycle. So let's break this life cycle, what actually it is. So if you see first 6 phase requirement analysis, in which actually you gather the information from the user, right? The second one is specification, where you prepare SRCs, software requirement. Uh, Software requirement is actually prepared, and then you go to the design phase, in which actually serves as a blueprint. And from this design phase, you actually go to this development phase, where actually you do this coding. Next is quality check and quality assurance, where actually the quality is being checked for, means the intention for which the software was developed, means has the software used the desired steps during its whole development. So this comes there. Next is acceptance and operations. So once the software has passed acceptance testing, it goes to the operation phase, where actually the software is being used by the user. And if I include this maintenance and end of support in this first 6 phase, it will give you the whole software development life cycle. Because once the software is being developed, which was the software process, if you add maintenance and end of support, means after a certain time period, it will be difficult to support a product, right? For example, Windows XP, we don't have support anymore for Windows XP. So that product has now ended. So there is no support for that product. So similar, so once you have last 2 stages there, the whole life cycle comes into the picture. But for our course, our main focus will be on the last 2 phase, software maintenance, where actually we are more interested in maintenance and end of support. When we can say the product has reached to its limit and we cannot do any more maintenance on it. So these two phases actually are for comes directly under software maintenance. So we are going to see only these two phases in the whole course. Now the question comes, why actually we should study maintenance? Tell me, like, what you think, why we should study maintenance? Or just to get 6 credits, we should study this software maintenance, right? Or is there anything else why we should study maintenance?
Even though it's released, but the customer may need some modification for their main add some shorter use bugs that have to use it. So for that part, maintenance is very important.
Okay, yeah, true. Anything else? Why we should study maintenance? So many of you might think like they after doing their masters they want to join any software company, right? Many of you might be thinking to join a software company. So in a software company, when you go, you will see like it's not only about doing coding things. It's more than coding. It's more than coding because like I told you, like it's not only about developing new things or just capturing user information and putting it in a piece of function and doing those tasks by your software. It's about maintenance. The first line, if you see, because maintenance consumes a major share of the software life cycle, financial resources, it should be an important project consideration. I will show you a data in which you will see like how much, like almost 90% of the whole efforts, time, and money this maintenance takes, and rest is being consumed by other SDLC phases. Maybe development and other parts can take let's say 9 and other can take 1, but almost 90% of resources actually is being consumed by software maintenance. So just see, if all resources of the whole company is being used in maintenance, so this can be a main factor why actually we want to know more about maintenance, why it is taking 90% of things of a software company, right? The second is during operation of the software, problem may be detected. Like he said, it is not like during the development phase you will be able to find bugs. It will always be like once the software is actually being used, then only you can identify different types of bugs or faults present in the software. So therefore, a maintenance effort is needed to cope with all these problems. Third is software maintenance is commonly related when upgrading system components. So this is also a factor. It might happen you have developed a banking system which was working in Windows XP. However, it may not work on Windows 10 or Windows 11. If you want to work, if you want to use the same software, you may need some emulation software which gives you live support with the help of which you are doing all those functionalities of the from the first software. But if you are using some emulation software which is giving you all those environment of Windows XP in your Windows 11, it may happen like the security. You may make your whole system lightly coupled, or you can say the whole system can compromised by easily by hackers. So there might be some security challenges also they are going to arise. So whenever there is a change in software surroundings. Surrounding here, actually, I mean software means the operating system where actually it is going to be worked. And like I told you, software maintenance actually is going to take a significant portion of the whole life cycle. Software maintenance is going to use different types of tools, methods, technologies. So we need to know what are the different tools, methods, and technologies. and then it is maintenance is required on all types of software. It doesn't matter whether if you have used a Python programming language and you say, so right now Python is being used everywhere, so this is an up-to-date programming language. It may happen like in next 5 or 10 years, it may get outdated, and you may have some other programming language, or maybe some other database from which you want to retrieve or send your information. So irrespective of what technology you use, maintenance is going to come. You cannot say the software that has been developed it is being developed using the most updated tools or programming language, anything you use, whichever technology you use, whichever language you use for doing the whole process, maintenance is going to come. This is something that you have to understand. Yeah, so this is exactly what I was telling you about. So if you see this, 93% of cost actually comes from software maintenance, 93. And if you see this, the rule of thumb, what it says, only 1% actually comes from the idea or proof of concept, and 10 euro, sorry, for example, I'm just converting it into percentage. If you convert it in percentage, it is 1, 10, and 90. So 1 euro you have to actually you are spending in idea and proof of concept. 10 euros, which is around 9 or 10%, 9 point something, will be you are investing in testing and developing product from that idea. However, 100 euros, which is almost 90%, you are going to spend in maintaining and in commercially supporting the whole product through its life. So this is exactly what we need to understand. It's not only about the idea like we are going to solve. Idea is only 1%. 10% is 9%. 9 to 10% is almost about this testing and developing. However, the whole maintenance cost is almost about 90%. It can go beyond 90, 91, 92. So this is exactly what I was trying to tell you. And this thing you are going to see more commonly in games industry. Why I'm saying games industry? Because most of the games industry, you see, what they do is they just build the initial setup where actually you can do some basic things in a gaming thing, and then they release their software for free for normal users. And based on the feedback that they get from the feedback actually which they get from the users who are using that gaming software, they do iterative modification in the software. Means they may add new features, they may add new initially it was for 2 players, now it can be used for multiple players. Now it may support more, it may have more graphical output, and so on. So in gaming industry, it is always seen the initial software that is being developed, it only has the basic thing. But when you do this iteration also comes under maintenance, right? What you are doing here is you are adding new features to the existing gaming software that was being used by the user. So this is something which you will see in gaming field, where iterative addition of features is commonly done. Yeah, so even though it is known to be a very big problem, you are going to see hardly anyone cares about software maintenance. It is seen as a last phenomena. Means as it comes last in the whole life cycle, it is also treated in the same way in the like you can see it in the whole life cycle. So priority for software maintenance is very less, despite of all this information, or at least if you compare with the other phase, for example, requirement gathering, testing, or software development, where actually the coding is being done. So this diagram, if you see ISO IEC 14764, this actually gives you the whole software maintenance process, how actually it goes on. So if you see the first page, in the first stage, it talks about process implementation. Actually, in process implementation, you need to find out what maintenance task you have to do, who is going to be in the maintenance team, you need to assign different roles to the people who will be there in the maintenance team, and then you need to identify what tools and techniques actually you are going to use in this process implementation phase. So first phase talks about the basic setup that you are going to use for the whole maintenance process. And if you see in this circle, there are three different steps which actually which moves like a circle, and they just move round and round, round and round. So the second phase, which actually is about problem and modification analysis. So here actually you see what actually is the user input, where actually he wants to do certain changes. So once the changes have been identified, then you technically you analyze what can be the ripple effect. Is there any ripple effect or not? What things can be done? Means if I'm changing this thing, does it going to have the impact only on that function or on the other function, and so on. So basically it is about the modification analysis. So once the modification is being done, what impact it is going to have. From phase 2, you go to phase 3, where actually the modification is being done and the implementation is being done. For example, whatever inputs you have for the modification, you do those modification, you do those testing. If the test fails, you go back, you just check what went wrong, and if you have identified the bug, again you fix it. You go forward, you do the testing, and once the test clears, you go to the next phase, which actually, so phase 4 is about maintenance review and acceptance, where actually you do this task, which what I was telling you. So once the modification is being implemented, you go to the phase 4, where actually you do this task, where you check whether this testing was done properly or not. If it is not being done properly, then again you go back to the second phase, where actually you see the initial analysis, whether the modification that you have done, is it the same modification that was intended to do. If it was not, then again you go back to stage 3, where again you do the modification, and you go back to stage 4, and so on. So this circle keeps moving on. Means it goes on and on. Nothing till the whole team is satisfied. It goes on. Next is stage 5, migration. This migration has its own step. Migration can be because there is perfect example is like the software which was designed for Windows Vista or Windows XP. Now, because of change of the operating system, it cannot be used anymore on the same operating system, and you need to migrate the whole software to a new operating system. And again, then you have to follow certain step. You need to analyze what things needs to be changed in the existing software, so that it can support the whole migration process. And once the changes have been done, what will be the impact? Again, the testing is going to be done, and so on. So step 5, migration, talks about when actually there is a change in the whole operating system. Step 6, retirement, end of life. Now the software have been reached to a certain limit. We cannot modify it anymore. It cannot be used with the existing environment. And now we are in a position to say that like we cannot provide you any more support. So in this case, the software has to be retired, right? Means it is not fit to be used anymore on that operating system, and it can be due to multiple reasons. For example, there have been so many changes in the software. Now it's not possible to do a few more changes, because the maintenance teams are not able to understand what impact it is going to have, and it will take more cost. So retirement 6 phase comes. So I hope you now you get a basic understanding what this the whole architecture is. This whole architecture is about the maintenance process internally, how actually it works, right? So within maintenance, we are seeing this, how actually the process works. Now there can be multiple. There are actually 4 types of maintenance, like I told you, there are some maintenance which came because there was some bugs, there was some faults that was identified. So when the user identifies bugs, faults in the software during its usage, that particular maintenance we generally call it as corrective maintenance. By the word corrective, it is understood corrective, right? We are doing certain corrections in the existing software. So when we are doing certain corrections in the existing software, that particular thing comes under corrective maintenance, right? Are you getting my point? When the corrective maintenance comes, when you have identified bugs or faults in the software. Second one is adaptive. So adaptive means the software is now being used. However, the whole environment has changed. Environment can be the physical hardware where it was used. Maybe earlier the software used to work with 2 GB of RAM and certain other specification. However, now because of more users or because of more data, it cannot be used anymore with the existing software. Means with the existing hardware, or the whole operating system has been changed. For example, the software. Now the software, the whole operating system has been changed and it cannot be run. The whole software cannot be run or executed in the same environment, or there has been some change in government policies or in business policies. So you need to change the whole software. So if there is a change in hardware, software, business policies, government policies, those things comes under adaptive maintenance. Now you need to adapt your software with these changes, right? These external changes. So it is very clear, right? Adapt. So there are changes in your external environment, and you need to adapt. So adaptive. Next is perfective uh, maintenance. Perfective. So now the user is using it, but there is no bugs. They have not identified any bugs. Everything is going well. But now he wants to do certain refinement. He don't want to use the whole software as it is, right? Means there can be a function. He don't want to use the same function as it is, or he may wants to add certain new additional add-on functions in the existing software. And this add-on features, which was not there initially, is not a bug, right? It is what we are doing here. It is we are making the software more perfect for the user because he needs more functionalities from the software. So in order to get more functionality, what we are trying to do here is we are trying to add certain users. We have captured few new user requirement and we are trying to put those requirements inside the whole software. So the word perfective means we are trying to make the software more perfect by adding more and more features. Next one is preventive. Preventive maintenance. Preventive maintenance means you want to do certain things today, so which may be very small, but it has a huge impact in future. So for example, you might see like there are certain software which release their upgrades, right? For any operating system, if you are using this Android, or if you're using Apple OS operating system, you are going to see they provide you certain upgrades, right? Why they are giving you certain upgrades? Because they don't want, because those upgrades actually are solving a particular problem which may become very big if they are not solved today. So this is a very simple example. Everyone does this. So you get an upgrade, you just do those upgrades. So those upgrades, things that you do on your mobile or on your PC, those things comes under preventive maintenance. They don't want the whole software to get corrupted. Instead of that, what they are doing right now is they are just giving you certain updates, or they may release certain patch which you can use on your device, and it is going to fix the problem which can have a very big consequence in future, not today. So this thing comes under preventive. So if you see a whole maintenance, the whole four things, by the name it is very clear what actually they want to do. Yeah, now if I talk about types of maintenance, even though the data is from 2008, if you Google it today also in 2023 or 24, you will still get the same overall same percentage. The percentage never goes up and down. It is still the same. If you see the whole, so what actually I'm trying to say from this figure is, for maintenance, now there are four different types of maintenance, right? It's not the general maintenance that we started few hours ago. It's not about that general maintenance. It is about different types of maintenance. So if you see in this diagram, 50% of the cost or the efforts are being used for making the software perfective. Means adding more and more features that users are asking to do, right? Once they are using the product. So 50% of whole effort is actually used during perfective maintenance. And the second one, if you see, is 25, which is adaptive. Corrective, where you actually find the bug, is only 21%, and preventive is just 4%, where you release some updates and you do certain changes in your software by your own. So it's only 4%. So by this actually pie chart, you can see the 50%. Why this 50% is coming? Because the example which I gave you, the gaming example. In the gaming example, these things happens iteratively. So once the user actually is using the gaming software, you are going to see they are going to give you certain inputs, based on which again a new version of game is going to be launched for the end user, and so on. Next is types of maintenance from aging. From aging point of view, we can also have four different types of maintenance. The first can be introductory stage, which actually emphasize on user support. So initially in the first phase, we are more interested about usability. So here maintenance is about how to make your software more usable to the end user. So how you can do it? We can do it by giving proper training. Means once the software is being developed, you can have a certain manual. You can give certain training to the user. They can follow those steps. They can follow those readings, and then they can actually use the intended software. So the first stage actually talks about the usability. The maintenance here is about how you can make this software more usable to the user. Second is growth stage, which actually emphasize on correcting faults. Now user knows how to use it. He is using it. Now when he starts using the software, he gets some errors or faults. Maybe the application is not doing the calculation, or it's not adding the numbers up to a certain limit. It works, but if he is giving a very large number, it is not doing those additions for you. So he has found some bugs and faults, and here the maintenance is about fixing those errors. It's not about usability. It is about fixing those errors that have been diagnosed by the users. Third is maturity, where the emphasis is on enhancement. Now it's not about identifying bugs, but it is about enhancement. Means now user wants to have few more features that he asked you initially. He wants to have some more things in the software compared to what he had in the first cycle, right? So the third maturity is about enhancement. How actually you're going to enhance your existing software. Fourth is decline, where the emphasis is on technology changes. As we know, the technology is going to change very rapidly. So once the particular software is being developed, it will be very difficult to support, or if you need to introduce some new, for example, there is a software, and for banking system, instead of using normal Oracle, you are using, for example, let's say you are using blockchain for storing the data. Now you have changed the technology here. So once the technology is being changed, so the whole maintenance process means, in this case, the maintenance process will be how you can make your software interact with the new database. How actually, what commands it actually needs to interact with the new technology. So the fourth step, which declining things comes under, if there is certain changes till till a limit you can do it, but after a certain limit it's not possible to do changes with every technology that has been done, means that has been changed in the software from the initial startup, means from the initial part it was developed, for example, using a certain language, a certain database, but now the whole thing has been changed iteratively and it cannot be supported anymore. So the fourth one is the decline thing. So yeah, so anything you want to ask, or I should move forward? Yeah, it is a little bit a theoretical class. So if it is a theoretical class, it is how it is, right? There's nothing much I can do. These keywords which are there in slides, they can be understood in a different way also. Means the meaning will be the same, but you can go more detailed. You can just follow those materials, and you can also go through what actually these things are in depth. Because in the class, I will try to give you the basic understanding what these things are. I will not go in very detailed thing. For example, unstructured code. So it's not possible for me to be here to show you an example, and then we will do some test. Okay, so this unstructured code is there. So it is something that I hope you are going to do by your own, right? So the concepts that is needed for the whole course I'm going to discuss, right? So most typical maintenance problems are unstructured code that actually we saw. What is unstructured coding, right? We saw one example of declaring a variable. It was very simple, unstructured coding things. Second is insufficient domain knowledge. Like I told you, the people who are going to do the software maintenance things, they will not be the same people who actually have developed the whole software, right? So if the people are different, if the documentation is not being done, if they cannot look for the process that was followed for the whole development of the software, then they may not identify what is the rationale behind a particular function, what actually that particular function is trying to do, right? In that case, this whole scenario comes under insufficient domain knowledge. They cannot figure it out what actually the particular function is trying to solve. Insufficient documentation, right? Again, so with every changes that you are doing from the initial startup, when you start doing, or when you have started doing, you have started developing the whole software, everything should be properly documented, and during changes also you need to do the same process. You need to follow the whole documentation. You need to mention what has been changed, why it has been changed, and so on. So these three are the main typical reasons or most typical maintenance problems that normally we face during software development, whole life cycle of software maintenance. And then we have different tools are there, which are easy to use, ready to be used kind of tools. You can go and you can just check online what are the different tools. For example, the first one talks about tools to ease perceptual processes, reformatters. So reformatters means these tools actually is going to take the whole source code as an input, and once it takes the whole source code as an input, it is going to give you the right indentation. It is going to align the whole classes, whole objects. It is going to give you certain comments statement if it is not there. So it will make the code more. It will make the code more logical to understand actually. Next, there are few tools to gain insight to gain insight in static structure. means static structure here actually it means for example if the whole code has been written, right? If the let's assume that like the whole code is being now written, and now you want to know what actually these functions are doing, even though you have not written those functions, but now you want to understand what these functions are actually trying to do. So you can use or you can go through different tools which can gives you an idea what actually these functions were designed to do some things. Third is dynamic behavior. During maintenance, it is also it is also like you also have certain tools which you can actually use. Once you do those modification, they can give you an environment where actually you can execute your software. And once you execute your software, it can give you how much memory it is consuming, what is like the transfer of data between the software and the machine and the server, what is the transfer rate, and so on. So all those dynamic information also you can get from this dynamic behavior tools, which can only come once the software actually is running. So you don't have to run, you can just use those tools. And there are few more tools which actually help us you to inspect what is the current version of the software by giving you its history, how many times it has been changed, what changes has been done. If it maintains means with the help of those tools, you can come up with the whole history of the changes that was done in the whole software. So you can just check what are these tools actually they are, and you can look for some open source tools, and you can try to do some experiments, and you can just check how actually they are working. Right. This is my last slide for the day. It talks about indicators of system decay. Right. As the system is being used after a certain point of time, it will not behave in the same manner as it used to behave in its initial phase. So with the time, the system is going to decay. Decay means it will not work as it was working in its initial phase. So there are 8 factors which actually can lead to a system decay. First is frequent failures. You have developed a software which is being by the user, but again and again there are some failures, means some bugs are coming on. You are fixing the bugs, you are giving it back to the user, right? But again, some failure again comes. So the whole software is being developed in such a way that the user gets this error, this faults, bugs so frequently that the system get decayed. This can be the main first reason. The second is overly complex structure. Now because of these changes, the whole software is now become so complex that it cannot be understood anymore for any human, even though you have documentation, but it's not possible to do few means it's not possible to understand the whole structure. The whole structure is now become so complex, it is easier or it is best to buy a new software. Means if you will invest time, it will be easier or it will be more cheaper to buy a new software than putting more time on that complex software because of multiple changes. Running in emulation mode, I told you about that. You have developed a software which was being used on Windows XP or any other things. But now Windows with Windows 10 or Windows 11, what you are doing is you are creating an external environment and you are using your existing software in this Windows 10 environment. But again, when like I told you, when you do this, some of the functionality may not work because you are giving some external you are giving some external you are giving it an external environment, I can tell you, for the software which was there in Windows XP, but this can lead to some security issues in the whole system. So this can also lead to the decay of the whole system. You have developed very large components. We saw what component is. Now the whole component is being developed that like it is not performing one task, however, it is performing more than 5 or 6 tasks. Let's take an example. So the modularity of the software is not there. It performs multiple tasks, and because it performs multiple tasks, it has a very large component. So if it has a very large component, again, it is going to lead to the whole system decay. Excessive resource excessive resource requirement. Earlier, the software used to take only it used to run only on 2 GB of RAM, but now it needs 16 GB of RAM. This is something also can lead to system decay because it is asking for more memory, more power supply. So it's inefficient to do some changes in the existing software. So this can also lead to the whole software to not to be used. Deficient documentation, it is self-explanatory. High personal turnover, you will also see people come, people go. So this is also a factor which can lead to system decay. If someone is aware, like I'm here for a few months, then he will do the task in the same way only. And this high turnover, if there is a high personal turnover in a company, then the chances of getting a software to be decayed is very high. Different technologies in one system, you have blended multiple different technologies compared to the language, database, whatnot. Whatever you have seen in the market, you have put everything together in a one machine. Now it's very difficult to do the maintenance because for every different technology, you need expertise on all different technologies. And the other problem is when you use multiple or different technologies, syncing each other, how they are going to work or how they are going to collaborate with each other is very difficult. You need to focus, means those things can also ultimately lead to system decay. So what we have seen today, so we have seen like software, most of the maintenance is inevitable. We cannot stop. It is going to come and it will come. So it's inevitable. Maintenance problem we saw is actually comes from these 4 things: unstructured code, insufficient domain knowledge, insufficient documentation. This is very important. Bad image of maintenance department. This is also there. And you know about this law, a system that is used will always change. Lemon's third law, right? Whatever system is being used, it is going to change. You cannot say it is fixed. You have solved the problem. It is being fixed. It will change. And whenever it will change, it needs certain maintenance, right? So what you should remember from this, the definition of software lifecycle and maintenance, and of course, what are the reasons why maintenance needs to happen. Yes, so do you have any other things to ask or